So, GNU radio blocks with JavaScript, building SDRs with JavaScript, and the caveat on that is soon. However, I am solidly getting into GNU radio, and by the end of this talk, I think you're going to realize that it's a little deceptive of a name, GNU radio. Yes, it is a platform that lets you build software-defined radios, but that's like calling a computer a machine that calculates. It can do a lot more. So, the first obvious quote, wow, the colors are literally inverted. Okay, we'll go with it. This is going to be interesting. Yes, so, GNU Radio, what is it? This is a screen cap of their website. I'm not online because we're at PhreakNIC. For those who've been here before, you'll get the joke. But yes, they officially call it a free and open source software development toolkit that provides signal processing blocks to implement software radios. And it's neat. And we're going to get into GNU Radio, something called GNU Radio Companion later, and you can literally do just that. One big point that I really want to stress is to get started with this, you actually don't need any hardware. So yes, I have a RTL SDR, and I can do interesting things with it, but I really actually don't need any hardware whatsoever, obviously aside from a computer, in order to do this. And so if I don't have any radio equipment, and like if you're not a licensed ham or you're just a software guy, which I actually am a ham, but that's another story, then yes, you can just build inside GNU Radio and just have a simulated environment. So this really is accessible to anyone who's technically inclined. There's a couple of ways to get started with this, and then I just want to get this stuff out of the way before getting into the interesting stuff. The absolute easiest way, but not the most performant way, is to just simply go to this website and grab the GNU Radio Live SDR environment, which I am going to demo later on. It's pretty amazing. Is someone able to close the back doors? It's coming up from there. It's kind of through on for a second. So yes, the pro is, it's a VirtualBox image, right? So you can just fire it up and there you have it, and you can get to work immediately. It's not the fastest, but still, Corning Labs came up with the VirtualBox image. Big thank you. It's very, very useful, and I know that they teach how to do GNU Radio, and that's why I came up with it. But still, great job on the project. So if you're a Windows user, don't imagine there's probably some number of you, but that's your URL to go to. I've installed this on pretty much everything except Windows. It's just not an interesting platform to me, aside from mobile development. We'll get into that in the hall. On OS X. Surprisingly, on the default Yosemite, you actually have to install a package manager in Python in order to access another package manager. So first you have to install pip, and then once you install pip, you need these dependencies. And then I'm going to say use homebrews. Actually, what's the breakdown in this room as far as operating systems? How many people Linux is their primary system? Okay, that's the next slide. How many people use Mac as their primary system? Almost, okay, well, I do too with Linux, which is funny because I'm the National Linux president, so you'll figure. And any Windows, anyone willing to admit Windows? Okay, more than I thought. Cool.
But not forever.
Do what?
Not forever.
Yeah.
Not for everything.
Any of these operating systems or tools, they all have their pros and cons. I think that's a fair statement. But yeah, if you are a Mac guy, really super easy job. All you got to do is literally that, run homebrew, tap and then install, and you're up and running. For Linux, you got it pretty easy also. It's literally just an apt-get install GNU Radio or a yum install, and you're up and running. If you want to grab the source, there you go. Although, me personally, I would sooner go to GitHub, GNU Radio, and then / GNU Radio again would be the main project. There are some other interesting repos that I'm not going to get into in this talk with that, but a little bit more background, and then we'll get into, again, the interesting stuff. So, one of the key components that we're going to look at is something called a GNU Radio block. And strictly speaking, it's just a discrete unit of functionality. It has inputs and has accepts inputs and has outputs. That's as bland of a description as you could possibly make, and I recognize that. But I just want to get some of this terminology out of the way. There are different types of blocks, and there's also different terms that you can use in these blocks. So essentially, if you haven't figured it out yet, you're essentially taking all these different blocks and you're linking them together, and then thus you have a radio. So with the block, you have a port, you have a source, you have a sink connection, your connection, your flow graph, and your flow graph is really the whole big project. And we're going to see some examples of these. Item string, IO signature. I'm not going to spend a whole lot of time because it'll become more apparent as we're actually using this stuff. So the big interface on this, strictly speaking, I'm pretty sure you can develop GNU Radio projects without Companion, although from my playing around with this, I don't know anyone who actually does that. Everyone uses this GUI interface. And it's pretty slick. In fact, it's actually a pretty nice little program. We're going to look at it momentarily. So GNU Radio Companion. Again, it's the graphical interface that allows you to do all the things. And another point on this is there is the core functionality of GNU Radio, and getting back to, and again, I'm sorry I'm front-loading so much theory on the front end. I just would rather get this out of the way first before, because there's a lot of demos I really want to show off. You have your core functionality, and then you have what are called out-of-tree modules. So remember back earlier when I mentioned that, strictly speaking, you don't have to have any hardware. Obviously, the project feels kind of boring without hardware, specifically radios, and so you're going to find all of that, in these auxiliary projects. The other big thing to note is that this is largely a Python project, and so even the idea of introducing JavaScript into GNU Radio is, so for anyone who knows what GitHub's supposed to look like, that's how inverted the screen is. That's actually a screenshot of GitHub. It's a very Python-centric project. And one of the things that I'm going to argue in this talk is the core of GNU Radio is built in C++, but the way you script with it is in Python. And the way that Python works, and I'm jumping a little ahead of myself, is using an interface that we're going to talk about that I'm really not a big fan of. And this is why I'm proposing another language and another way to interface back into that core C++ program. But PyBombs is a great way of actually managing dependencies in GNU Radio. Of course, like any good project, it's got its own package repository. If anyone's familiar with CPAN from Perl, this is kind of the GNU Radio equivalent thereof. And so some use cases. There's a lot of use cases for this stuff. Two really interesting examples is that really caught my attention. This is a research paper of somebody who basically took this interface, which I'm realizing now I should have put this all after showing you GNU Radio Companion. But they were basically able to slap some other open source projects into GNU Radio and replace LabVIEW. Is anyone familiar with LabVIEW as a program? That's pretty neat because LabVIEW is not cheap. Another person is using this to do interballoon data relay using software-defined radios, or in other words, paving the way for distributed space systems. So you could actually build out, first, and there's a big assumption that I'm making. How many people in this room have never heard of the term software-defined radio? Because I keep using that as a given. Is anyone, okay, so very quickly, it's what it sounds like. So with a software-defined radio, you're essentially writing radios as programs, rather than having traditional physical hardware to do all of the various things that you need in order to get out a coherent signal. There's a lot of implications of that. So let's finally talk about GNU Radio Companion. Of course, for whatever reason, the colors are going to be inverted, so this will be fun. So first, I actually want to show off that VirtualBox image that I was talking about earlier. Okay. might just shut that off. Oh. Oh, that's what's going on. Okay. So apparently I have a second screen. That's fun. We'll see how useful that is. So we're going to finally launch GNU Radio Companion. And actually, that's going to get annoying very quickly, so sorry. Let me go ahead and collapse that.
Hit Control Option Command 8, and that'll invert the color on the
Command
screen.
Option.
Control Option Command 8. No.
Okay.
Here's the first color.
Man, this is really trippy. But that's largely coherent. That makes no sense. Okay, we'll just go with it. So, GNU Radio Companion, a few things I want to point out. These are these blocks I'm talking about, right? So they're broken down into different categories: audio, Boolean operations, byte operators, all the way down to GSM, Fourier analysis. I mean, you can get really, kind of fancy with this stuff. I'm not going to spend a lot of time, building out. Here's your sinks, these are your sources. If I wanted to, instance, have a source, maybe the RTL SDR, which of course I really need to plug this thing in if I really want this to actually work. I could have a source, and then I could have, some kind of operator, and then shift, click on this, or use control this. Make sure that makes sense. Really? Key bindings correct. I'll go ahead and get into the actual demos on this. One of the things that I really like about this is that you actually have a number of demos. This is one such example. What this will do, and I'm bringing up this particular example for a few reasons. So this is what a GNU radio, this is a flow graph, right? This is an example of a flow graph.
Hey, can you move that microphone closer to you?
Yeah, so this is an example of a flow graph. And, okay, yeah, so am I any more coherent? Okay, so yeah, due to the resolution of the screen, it's kind of hard to get all of this up here at once. But if we actually run this, I'm not hearing it. And this should be a smoother sound, because I'm going to run the same example on the Mac natively. And and the reason why I'm bringing this up is this is the performance hit you're taking by running in a VirtualBox. So this gets you up and running very quickly, but if you wanted to actually do things outside of training, I really recommend a local install, and that's the point of this demo.
And the debug window shows you that the UAs are underruns.
Yes, that's a very, very good point. And by the way, you might be thinking, well, maybe you're just under-resourcing this virtual machine. So let me actually go ahead and power off this virtual machine, and wow, that's crazy. Settings. Okay, so I'm giving this thing 8 gigs of RAM. I'm giving this thing 6 processors. I have so it's not an under-resourced thing. It's just for whatever reason, So one limitation of software-defined radios is that, and it's not really a limitation, it's inherent to software-defined radios, they're very time-sensitive, right? So if you have a lot of delay, that's not good. But let's run that exact demo now using Mac. So let's do Radio Companion. So weird that if it's in the background, it's inverted. If it's okay. So now I'm actually not going to run that version of it because I screwed it up earlier. Open up this version. Examples. And let's run that. So you can tell that's how much delay you were dealing with. So, practically to the point of unusable. Yeah. Oh, and by the way, Python will crash on you all the time, especially on Mac. I'm not 100% sure why that's occurring, but that's maybe it doesn't on Linux, but on Mac it certainly does. And of course, there's a whole lot of other demos that we can get into. Everything from there's everything from Noah examples to really the sky's the limit. If it's anything from an AM transmitter to an FM transmitter or receiver, if it's a radio design you can think of, you could implement it in GRC. So currently, and the thing that I need to actually show you next is how you actually build those blocks, because that's key to really the whole operation. The core of GNU Radio and its API is a C++ API. However, you script, and I think I'm accurate on this, but GNU Radio Companion is built in Python. And so and Python in and of itself isn't bad. I don't hate Python. What I do hate, it's this thing called swig, right? And so the thing is, if in a perfect world, you would probably write everything in I don't think the word perfect world and C++ ever belong in the same sentence. But ideally you would want a compiled language that is using that's as fast as C++, which is arguably slower to, well, actually it's not arguably, it just is slower to develop. It can get a lot more complex, and it's not a scripting language. There's some people that might argue with me on that point, because there is a way to, I don't want to go down that rabbit hole. Python, one thing you have to hand Python is that it's fast. You can crank out blocks very, very quickly. It's a lot slower to execute. And so the way it's actually working is it's used, so Swig is essentially an API wrapper that's basically calling the C++ code from Python. And the thing is, so you built out this entire project in Python, and then when you are ready to go to production, you might have to end up rewriting, large parts of it in C++ anyway. So you've now added, double development time. And there's actually a client project that I'm working on now in the OpenCV world, computer vision world, where, and I'm not going to name any names, but they wrote everything in Python, and now I'm having to make it work on a mobile device, which means it has to be C++. And I was like, why didn't they just write it in C++ the first time? But they needed that scripting ability, because with a scripting language, you can rapidly prototype, and that's one of the great things about that. So, the big what if is, what if you had the speed of C++, but the development speed of Python, and where this is going, but I promise that I'm not insane when I propose it because of how I'm going to inject it. And that's a lot trickier than I originally expected it to look, because again, the screen's inverted. But yes, in serious not trolling, there is a way to actually make Python be more performant than, or JavaScript be more performant than the way that they're injecting Python into GNU Radio Companion. And so again, this combination of Swig and Python, not ideal. It works for simple functions and so on and so forth, but to do much more complicated stuff, I can see where GNU Radio project is going to eventually have problems if they're not already. Funny enough, there actually is a program called Hyperloop Abstraction Layer, or HAL, by Accelerator, and that's really the world I come from, is mobile app development. And that's what Codex Labs does. We're basically, the Codex Labs to Accelerator is the same, it's kind of the same relationship that Corgan Labs has to GNU Radio. And so with that, so one of the best arguments or posts that I've seen regarding the whole SWIG issue is this one. It should be showing me the URL. Oh, the URL is buried. Yeah, when I show you the repo where I'm putting all this stuff, I'll source this so that you can actually read about this. But I've worked with SWIG. In previous projects, namely there's a game engine out there called Platino that allows you to write cross-platform video games. And we use SWIG for physics. It sucked, and it was horrible. And until version 3.0 of Platino, physics are a joke. They were terrible. But SWIG is great at automatically, and that's the key word, is auto-generated code, right? But again, you're taking on overhead, and a fair amount of overhead. Okay, so this is that best discussion that I was, I'm glad I sourced that. And again, the slides will be made available. And then this website's not live yet, and there's a GitHub repo that's going to ultimately come out of. And I'm going to actually post real benchmarks. I hate using the time excuse, but it's legitimate. I just didn't have time to properly benchmark this, and so I hate that you're kind of taking it on my word, but I'll have numbers to back this up, by December. So let's talk about, briefly HAL and how this will actually all come together. So again, HAL is this cross-platform, standard-compliant C++11 library. Yes, it is a wrapper, but I would argue it's a lot more performant. It's a wrapper, kind of. What you are ultimately doing is you're ultimately ending up with C++ objects out of writing JavaScript. And I really think that this project needs to be brought into GNU Radio by way of a project that I'm launching, as I said, at the end of this month called SDRJS. And with that, we're able to use the niceties out of C++11 to make this possible. So let me get into these two examples. Cool. Okay, so in this example, what we were looking at, and this is still just making the case for JavaScript into C++. So in this example, we are looking at a C++ program. And so one of the things I'm trying to clean up is where you would have actual independent JavaScript files. But essentially this JavaScript is being ran and ultimately being compiled into a JavaScript into a C++ context. And you're running it near the speed of C++. Significantly less overhead. Again, I'll post the benchmarks on this to show that this literally is not smoke and mirrors. The other example, and so with that dial tone, or I didn't show you the dial tone example, but you can also do a dial tone. You can see trivially how you would take, and this is an example of a simple block, you can see trivially how you would take, wish I didn't close that other one, how you would take something like this, because essentially you just need your HAL, which is actually inside this. You would drop that in, and essentially you would be, so it's not really introducing JavaScript blocks per se, even though at the end of the day you are. It's really saying JavaScript injected into C++ without the overhead of SWIG, is what I'm really arguing. Because the bottom line is, if they're going to keep Python, in the GNU Radio thing, I'm really interested in hearing why they didn't go with like PyBoost or a different way of injecting, because it's that SWIG component I'm not a big fan of. And I think it would be, and if they got rid of that, I think it would be a lot less necessary to rewrite your code as you need more and more performance. You could, And then, yeah, so I'm launching that, and then this is going to be the GitHub repo. That's still private, but I am taking that public, so you'll be able to see, some of this at midnight tonight. So far, any questions? Because I know I blew through a lot of information really fast. Okay.
Commercial interests? You're not doing this just as a total hobby because you don't have anything better to do?
So, yes and no. This particular project right now isn't necessarily commercial at the moment, or won't be. What I will be doing with Codex Labs is expanding training into GNU Radio. I don't want to go directly head-to-head with Corgan Labs. I need to reach out to them and try to find, because I think there's room for more than one player in that market. I think that GNU Radio is massively not marketed enough and not talked about enough. And again, when you can use something like GNU Radio Companion to help replace something like Labs, that in and of itself, it's a whole area of training. I know for a fact they're not even touching it. They're just only showing you, as far as I can tell from looking at their website, they're just showing you how to use GNU Radio, as a program. And they're, if they didn't develop, they were certainly huge advocates of the Python and C++ routes. And I think that, they've done a lot of, the whole community's done a lot of amazing work. I'm just not a big fan of the swig approach. And so, one more thing that's a little uncomfortable that I've got to get into with regard to National 2600, since we're being recorded, I'm just throwing this out there. So last year I bailed them out, the National 2600 big time.
As president of National 2600 last year, I will confirm that, and that was the second time this man has saved PhreakNIC. So
yeah, I sponsored in 2012, and that was, zero return out of that. But it's a great conference, so that wasn't at all mad or butthurt about that. A year after the fact, eventually Codex Labs needs to get paid back. Currently, we are doing Codex Cast subscriptions, as a way of people who sign up for that. $100 gets knocked off the debt, so on and so forth. But yeah, I'm just putting a little bit of pressure on 2600, the organization, that if at the end
the
of
nonprofit needs to pay its debts. I'm Johnny X, and I endorse that statement.
So, and also Keith Watson, because you want to talk about that one, Drew?
Yeah, Keith Watson, who ran our network, King of the Hill. He's a big InfoSec guy at Georgia Tech. He runs the DC 404 list down in Atlanta, and he is one hell of a guy. I've worked with him for years at DragonCon. The nonprofit needs to pay his hotel bill for last year.
Yep. So, any questions on GNU Radio? There's a lot I didn't talk about. So we have, and I intentionally ran fast so that we would have plenty of time to get into questions, because I still have about 30 minutes left.
Let me see that.
Yes.
So I'm not really familiar with Accelerator so much. Is that based on V8 or is it a different JavaScript engine?
So, Accelerator's been around since 2007, and what they do, they have a product called Titanium, which is open source also. And that allows you, on iOS, they're using JavaScript core, and on Android they're using V8, and they're a way. So they were doing a lot of the things React Native was doing before React Native existed, or before NativeScript existed. In fact, actually NativeScript, I can argue that they essentially more or less stole Hyperloop from Accelerator and iterated and did their own thing. But and that's what I teach. That's what Codex Labs is. So if you want to learn how to build actual native apps, but you use JavaScript and you end up with those different apps, that's what it is. I'm just saying they have some really interesting JavaScript technologies that could really benefit something like GNU Radio. Any other questions? Drew.
Are you going to do any demos with the actual hardware so we can do fun things like monitor aircraft in flight and stuff like that?
We have time for that. So this is a use case of GNU Radio where it's kind of opaque. because I'm not using GNU Radio Companion to actually pull this off. But if we want to see an example, so there is a program out there called 1090. Let's see. Yeah, actually wasn't prepared for that question. Let me actually drop the connection really fast and then I'll pull that program up and we'll look at that. So while I'm pulling that up, any other questions? Yes.
Have you played around with a HackRF?
I really want to get my hands on a HackRF. It's come down to time and not being able to grab one of those. Does anyone here have a HackRF? Okay. And what are you doing with the HackRF currently? And I'll start with you and I'll go with you.
I've played with some VHF radio stuff with it. I'm trying to do data from a few spots, and also just the same kind of stuff you do with the RTL, SDR, just seeing random traffic and then seeing if I can replay it and do some other stuff. Nothing too fancy.
Okay, and then what do you do with the HackRF?
Mostly teach myself how to use GNU radio.
So what are you doing with GNU Radio? What's your use case?
I'm just kind of a newbie ham, so I'm trying to get my feet wet into it. It's looking really cool, and so I've gotten about as far as making like an FM radio, going through tutorials I can find. So nothing really special case. I mean, I'd like to get into like collecting some drone telemetry, and I know our hackerspace in St. Louis does some high altitude ones and stuff, so pick up some of those signals.
Yeah, I'm trying to find my 1090 program. I literally just had this. Yeah, I don't know where that went on.
But my goal is that will one quick use case that I heard, because I think it'd be fun to try to.
Yeah, I'm not finding that, which is weird.
Because I'm right off of
So, yeah, are there any other questions?
even without my website, especially if we ever put up any. I know that.
Yeah. I don't know why I'm not finding that program. I literally just had it yesterday.
I know you're using this.
You can do a video demo of it online, share it with everybody later.
Yeah. All right. Well, yeah, I'll go ahead and punt on that one because I was just playing with that program literally yesterday. I was actually showing it off to Drew. I'm not seeing
I think it's
it.
a thing.
Yeah, no, it is.
I think it's fresher than all the stuff. So little.
I'll go ahead and throw this on.
Working database.
So anything else?
The thing about Baker,
All right, I'll go ahead and call it 20 minutes early.